This is my week 3 entry on low carb diets. The National Academy of Science considers an acceptable carbohydrate intake range to be anywhere from 45 to 65%. Anything less than 45% is a low carb diet. Now, 0 to 45 is a pretty large range, so it does not make sense to consider all low carb diets together. Instead, it's easy to break that into two parts. Very low carb diets are those between 0 and 20%, and low carb diets are those between 21 and 44%. What might a very low carb breakfast, lunch, or dinner look like? I chose dinner, and that would be something like a grilled fish, which my personal favorites are salmon or grouper, a broccoli or another vegetable, salad, a glass of wine, always a plus in my book, and sugar-free Jell-O if you're looking for something sweet. Considering only diets that with a carbohydrate intake of less than 20% that were longer than 6 months, what was the effects in compared to low-fat or non-low carb diets on LDL, HDL, and triacylglycerides? Well, they found that the LDL levels were not changed from baseline. HDL levels did go up, which is good, and the triacylglyceride levels went down. Considering only studies where the carbohydrate intake was between 20 and 40%, and the study went on for longer than 6 months, what was the effects of these diets compared to low-fat or non-low carb diets on the LDL, HDL, and triacylglycerides? They found that there wasn't much, maybe a slight lowering on the LDL levels. Only one study showed any significant change, however. The HDL levels, there were either no change or a slight increase, and there was a lowering of the triacylglyceride levels. Do low-carb diets reduce markers of inflammation? Well, that kind of depends on what your risk was. If you are of low risk, then you actually saw an increase on the markers of inflammation. However, if you're like most Americans, you are of high risk, and you did see a decrease in the reduction of markers of inflammation. What may be the real most important variable that determines if weight loss diet may be effective, and how do we know this? Well, the most important thing is sticking with the diet, adherence. If you're not sticking with a diet, don't start a diet. It's kind of useless. And we know this because after studying 4 diets and comparing them, the Atkins, Zone, Weight Watchers, and Amish diet, the weight loss were the same across the board for all 4 diets. The adherence over a year was also the same, slowly tapering off at the end of the year. The HDL levels went up for all of the diets, relatively the same amount. There was the same CRP decrease across the board for all the diets, and insulin was also reduced at about the same level for all 4 diets. And that meant that all 4 diets did result in weight loss, so long as people stuck with them. So my something new is an article I found called The Downregulation of Mutant P53 Levels via Glucose Restriction. It was published by Rodriguez and others in the Cell Cycle Journal. Now, this is a larger study that was done that looked at the glucose restriction and its effects on this mutant P53. It looked at everything from the cellular level all the way through to a mouse model. Now, this, of course, is a mouse study, but it is one of the first of its kind to approach how diet may possibly affect a mutant P53. So what is this mutant P53? Well, first, wild-type P53 is a gene that causes a cell to undergo apoptosis. So when a cell goes bad, this wild-type gene turns on and the cell dies, which is a good thing when the cell isn't a healthy cell. You want to get rid of these bad cells, or unfortunately, they tend to become cancerous. And with that, this mutant P53 is unfortunately found in many human cancer cells. So I'm going to skip past all of the cell work that they did and just focus in on the dietary restrictions that they did in mice. And what they did here was they took 3 different diets: a standard lab diet, a low-carb diet, and a chow diet, which is a high-carb diet. And all of them were the energetic calorie power were the same, except for they took out the calories from carbohydrates in the low-carb diet and replaced it with a protein. And then they took they randomized 2 sets of mice, your wild type mice and your transgenic P53 mice, and they began to feed them one of these 3 diets. And they assessed the blood glucose levels of the mice after several months on these diets and showed that there was a reduction in the fasting glucose levels in the low-carb diet versus the chow diet, which is your high-carb diet. They also showed that the low-carb diet led to a depletion of the mutant P53, but not in the wild type P53, which is good. You want to keep those wild type, but get rid of the mutant ones. And in a transgenic model, they showed that the dietary restriction of carbohydrates prevented the accumulation of the P53 mutation, and thus reducing the proliferation of this mutation. Next, they wanted to look at how low-carb diet influences P53 levels in developing tumor. So they did a tumor transplant into a nude mouse and again went back to feeding them one of three different diets, and found that the low-carb diet eliminates the oncogenic functions of the mutant P53. So not only do some mutant P53s not undergo apoptosis, they also pick up other functions that cause them to replicate more, thus becoming cancerous and malignant. In a different mutation, in a mouse that had a different mutation, unfortunately they found that it was able to pick up this P53 mutation as well, which suggests that that mouse may have had a separate oncogenic function, which needed to be looked at further. This study does not cover that portion. Overall, though, they did find that low-carb diet does lowers fasting glucose levels, lowers a P53 mutation level, and eliminates the oncogenic function of this P53 mutation. So what they would like to do is ultimately expand this beyond just a P53 mutation, because not all human cancer cells see this. There are other mutations that can cause cancer and malignant forms of cancer. And of course, more importantly, let's take this beyond a mouse model, which is a great start, and take it to a human model, which shouldn't be too difficult in that they would just need to find a large sample of cancer patients that show this P53 mutation and ultimately go through a diet randomized trial and see whether or not this low-carb diet has an effect on human cancer cells. But overall, I found it a very fascinating article, and I hope you did too.